Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new episode of Stories from Space podcast, where your host, Matthew Williams, examines the history of human spaceflight, the breakthroughs that revolutionized our understanding of the universe and our place in it, and the brave individuals who work tirelessly to advance the frontiers of our understanding. Knowledge is power, now more than ever.
The authors acknowledge that this podcast was recorded on the traditional, unceded lands of the Lekwungen peoples. Hello, and welcome back to Stories from Space. I'm your host, Matt Williams. And today, I wanted to talk about something that is long overdue. I've said this many times before, but looking through all the episodes that we have released on this podcast for the past 3 years, that's right, this show recently reached its 3rd anniversary. In any case, I was astounded, shocked even, to notice that I hadn't done an episode that was dedicated to megastructures, which is, as I've said many times before, a subject that is very near and dear to my heart. But this one, definitely top 5. Right up there with terraforming, the Fermi paradox, the Great Filter hypothesis, and red dwarf habitability, I'd say. It's one of the things that keeps me interested. In any case, what are megastructures, you may be wondering? Well, if you are not a fan of science fiction, or not someone who has been following the news in space and astronomy now for the past few years, and were aware of Tabitha's star and the controversy surrounding it, megastructures are essentially massive creations that could only be built by a technologically advanced civilization, and they're the types of structures that are so large they could encompass an entire star system, or even more, even grander than that. The idea being that in their ongoing quest for living space, creatures would eventually turn normal matter in their systems, in their star systems, into massive structures that would provide endless room for the species to grow and multiply, and at the same time, just inexhaustible energy from the star itself. And interestingly enough, the first recorded mention of megastructures came from science fiction author Olaf Stapleton in his 1937 novel Star Maker. He described how humanity, in the future, quote, began to avail itself of the energies of its stars upon a scale hitherto unimagined. Not only was every solar system now surrounded by a gauze of light traps, which focused the escaping solar energy for intelligent use, so that the whole galaxy was dimmed, but many stars that were not suited to be suns were disintegrated and rifled of their prodigious stores of subatomic energy. However, the concept did not become popularized, nor did it become a matter of scientific research, until the 1960s, and this was thanks to British-American theoretical physicist and mathematician Dr. Freeman Dyson. In 1960, he published a paper titled Search for Artificial Stellar Sources of Infrared Radiation. And in this paper, he described how advanced civilizations might reach a point of technical development where they could create a massive spherical structure that would enclose their entire solar system, and this would give them endless living space and energy. In fact, it was his words from the paper that I quoted earlier. Specifically, he said, quote, "We have no direct knowledge of the material conditions which these beings would encounter in their search for Lebensraum, or living space. We therefore consider what would be the likely course of events if these beings had originated in a solar system identical to ours. And skipping ahead, he said, "It seems then a reasonable expectation that, barring accidents, Malthusian pressures will ultimately drive an intelligent species to adopt some such efficient exploitation of its available resources. One should expect that, within a few thousand years of its entering the stage of industrial development, any intelligent species should be found occupying an artificial biosphere which completely surrounds its parent star." And the point of the paper, interestingly enough, was actually suggesting this as a possible technosignature, something that SETI researchers could be looking for by looking for sources of infrared radiation, which would be the sphere radiating heat energy from the absorption of their star's energy, something that they would have to do, that by radiating this out into space, they would be producing a very large infrared signature. In particular, these sources would appear unexpectedly in certain areas. Basically, in this region where we thought we would find a star, it's invisible to our optical telescopes, but looking in the infrared, we see a large source there. Dyson was saying that this is something that SETI researchers could be on the lookout for. And just a few years later, this was followed up on with the Kardashev scale, which is also an integral part of any discussion about megastructures. And as we noted in a previous episode that was dedicated to the life and accomplishments of the Soviet-Russian SETI researcher and astrophysicist Nikolai Kardashev, this scale came to us via a research paper that he published back in 1964 titled "Transmission of Information by Extraterrestrial Civilizations." And rather interestingly, it was kind of a footnote in his paper, the idea of a scale by which civilizations could be assessed or divided or classified. Whereas the main point of the paper was what kind of transmission energies and technologies can we expect to find out there, and what should we be looking for? That was essentially his purpose with the paper. And yet, it was the idea of civilizations achieving greater and greater levels of technological mastery and occupying greater and greater volumes of space and harnessing more energy from them. That was what really got people's attention. And so, in his paper, he basically stated that civilizations could be broken down into three types. Type 1 civilizations are known as planetary ones. They are those who can harness and store all of the energy of their home planet. This type of civilization would be able to harness what he estimated 4 times 10 to the 19 ergs per second, which would likely consist of fusion power, antimatter, and renewable energy on a global scale. Meanwhile, the next step in his mind was Type 2 civilizations, known as stellar civilizations. And these would be those who had advanced to the point where they could harvest all the energy emitted by their star. And Kardashev speculated that this would involve a megastructure, and he actually mentioned a Dyson sphere by name as an example of what this kind of civilization would look like and how they would go about harnessing the energy of their star, and that they would be able to harvest exponentially more energy, 4 times 10 to the 33rd power ergs per second. And third and last in his scale was the galactic civilizations, or Type 3. And this would apply to species that could harness the energy of an entire galaxy. And that would be energy consumption on the order of 4 times 10 to the power of 44 ergs per second. And over the years, many revisions, challenges, or even alternatives have been brought up here. And Carl Sagan weighed in on this. And it was in his 1973 book, The Cosmic Connection, An Extraterrestrial Perspective. And he said, a Type 1 civilization is able to muster, for communication purposes, the equivalent of the entire present output of the planet Earth, which is now used for heating, electricity, transportation, and so on. A large variety of purposes other than communication with extraterrestrial civilizations. By definition, the Earth is not yet a Type 1 civilization. A combined energy information characterization of our present global terrestrial society is Type 0.7. And as I said, there's been many suggestions for revision or changing the basis of the Kardashev scale, and also the inclusion of type 4 or 5 rankings. And this would apply to civilizations, just going by the order of magnitude growth, that could harness the power of an entire universe or multiple universes. Alas, it was this scale, along with Dr. Freeman Dyson's proposal of the megastructure, which came to be known as the Dyson sphere, that are the core principles, or core ideas of megastructures and whether or not extraterrestrials out there have actually achieved the level of technological mastery where they could build these things. And in all cases, it's important to note, with Kardashev, Dyson, and all other scientists who made these theoretical predictions of what an advanced species, and this included humanity someday, what they could achieve, what they could build to facilitate further growth across their own star systems and beyond, it was always tied to the search for extraterrestrial intelligence. Right? These were not just theoretical games and neat ideas that scientists created little mock-ups for. It was all about predicting the kind of technosignatures that could be out there so as to guide the search for extraterrestrial intelligence for SETI researchers, how they should set their expectations, set their instruments, and so forth. And much like the Kardashev scale, Dyson's proposal of a massive star-enclosing structure, that inspired many, many, many other proposals, and they have come to be known as Dyson structures collectively. And like the idea of the Dyson sphere itself, they are very imaginative, creative, and it is really immensely awesome to think that such feats of engineering would be possible given the necessary resources and the necessary technology and the necessary commitment. So, let's get into some examples. First off, you have the aforementioned Dyson sphere, and that would consist of a giant enclosing structure there that wraps around the whole star and essentially makes it invisible to the outside universe. Although the heat signatures it would produce, as Dyson said in his proposal paper, those could still be detected. Now, inside that volume, what would life look like? And in all probability, the species responsible, so in this case, let's say humanity built it, we would create continents and oceans and landmasses that covered the entire interior structure. And these places are receiving constant sunshine, unless, of course, you introduce a solar blinder, right? Basically something that would pass between the sun and your section of the sphere so as to simulate day-night, and it would revolve around inside this massive sphere in order to do so. And meanwhile, the sphere itself, future humans, like any other advanced species, would be likely to impart rotation to it. This may not even be necessary, really, because, of course, when you're thinking about gravity, the amount of material used to make the shell might just be enough in order to impart enough gravity that everybody feels like they're standing on a planet. However, imparting a rotation would be smart because then you can ensure that everyone inside the sphere, at least in the equatorial regions, are experiencing the full force of 1g gravity. And that would be a very, very interesting thing to see there. If the entire shell interior is to be habitable, then those who live around the polar regions would be experiencing less in the way of gravity. So, in fact, people needing to migrate or just travel throughout their lives in order to get the benefits of a full G gravity while otherwise living in environments where you're lighter in your steps and people would be capable of flying with very little assistance, perhaps a set of wings, and they'd be capable of recreational flight or even travel that way. And all the while, all of the sun's energy is being soaked up by endless arrays of sophisticated solar collectors, and such an advanced civilization that's capable of building the shell in the first place would likely have already figured out fusion reactions and so forth. But all that solar energy would be there, and of course it would be very, very useful in agricultural operations. So basically, you're imagining sort of the state of Earth in its optimal technological state that we can envision at this point, but spread out over a volume that is just several orders of magnitude larger. So it could support a human population in the trillions. Of course, there are those who would ask, well, what about the outside universe? Are we no longer in contact with it? Are we no longer observing it? Are we just living inside this shell and forgetting about everything else in the cosmos? But in fact, trips to the other side of the shell, to the outer shell, this could be a regular phenomenon there, and radio observatories and telescopes and everything needed for astronomical observations and cosmology, they could all be mounted on the outside, and people would have the benefit, possibly even as a sort of a tourism venture, to transport themselves from one side of the shell over, basically taking an elevator down or shuttle down into what they see as the Earth's surface, and then popping out on the other side, where they would once again be experiencing lower gravity, as those people who live around the polar regions would, and being able to see space and the stars. Unfortunately, you wouldn't be able to see the other planets because, in all likelihood, they've all been disassembled in order to create this massive shell. So, Mercury and Venus would not be orbiting within the volume, the Dyson sphere. They would have been broken up for materials, as well as Mars, likely, and the Moon. And in all probability, depending on whose estimates you consult, the entire solar system. In fact, some estimates indicate there's not enough material in the solar system for us to build a Dyson sphere that would have the necessary volume and thickness to generate enough gravity and also protect against cosmic rays and large projectiles such as asteroids and comets, and possibly even rogue planets, which could potentially swing through our solar system in the future. And of course, getting rid of the outer planets would also mean that our solar system, what's left of it in the shell, would be more vulnerable to interstellar objects, which pulled into the system. We no longer have the gas giants to run defense for Earth, basically, to absorb any impacts and any interlopers or capture them in their gravity. So these and other issues are problems that plague the idea of a Dyson sphere. However, it does remain a very, very cool concept, and certainly if you're a highly advanced species concerned about living space and that your species isn't going to have enough room to accommodate all of its people within the solar system as it is, this is certainly a way of addressing that. And science fiction has certainly incorporated this concept there into a few franchises, a few shows. A good example is Star Trek. I can recall an episode in The Next Generation, and I believe it was the one where James Doohan guest starred and he was reprising his role as Scotty, where he was on a ship that crashed on the surface of a Dyson sphere. And as the crew observed, this Dyson sphere did have portals that led to the inside there, so it was like a massive space station or facility. And it did have docking mechanisms in its outer shell and giant airlocks that would allow ships to pass in and out. So, yeah, space travel would still be possible with such a structure in place. Now, Larry Niven came up with a variation on this, and he even wrote it into a science fiction book. He called it Ringworld. And this was his answer to the Dyson sphere. And as he described it in the foreword of the novel, Ringworld, I myself have dreamed up a structure intermediate between Dyson spheres and planets. Build a ring 93 miles in radius, one Earth orbit around the sun. If we have the mass of Jupiter to work with, and if we make it 1,000 miles wide, we get a thickness of about 1,000 feet for the base. And the structure has come to be known as a Niven ring, alternately as a Dyson ring for variations thereof. And similar to the Dyson sphere, this ring would orbit around a star within its habitable zone, so the entire band within the ring would have exposure to sunlight and be able to absorb all that energy. And thanks to its rotation as a ring, it would impart centripetal force, which could simulate artificial gravity, though the thickness of the ring itself would impart some gravity already. And again, protocols would have to be in place, like a star shade that rotated with the ring, to ensure that every region experienced nighttime at some point, because otherwise their diurnal cycles of all the creatures living there would be disrupted. So, nevertheless, you get endless living space compared to life on our planet. And this idea has been popularized immensely thanks to franchises like Halo, the popular video game which spawned adaptations in the form of miniseries and movies, and also several novels and animated series. And the focal point of these stories, in all cases, it has to do with an interstellar war between humanity and a number of alien species that are all concerned with the halos, the rings, which are essentially a weapon of mass destruction, capable of sterilizing the entire quadrant of a galaxy, but which also have a terraformed surface, courtesy of the artificial intelligence that is looking over the place, that is essentially its custodian. So species of all kinds in the story can live there. And I would be remiss if I didn't mention other extensions or additions of the Dyson sphere concept. There are also what is known as Dyson swarms, or islands in space. All these basic ideas are similar to Dyson's original concept in that they speculate that extraterrestrials would use the material of their solar system to build these massive islands or clouds, really, of material that orbit the sun, absorb the energy, and in the former case provide, as we've said, living space and accommodations for terrestrial beings and species. The swarm, on the other hand, that is one that has produced some very, very imaginative concepts, which include the matryoshka brain. And this concept was originally proposed by astronomer and SETI researcher Robert Bradbury, not to be confused with the late great science fiction author Ray Bradbury. And he originally proposed what he called a Jupiter brain, which was a similar idea but on a smaller scale. And the matryoshka brain was scaled up to conceive of using our star as a stellar engine that would provide the necessary energy to drive computer systems. And the name itself is based on the idea of resting dolls, or Russian matryoshka dolls, that would be made up of layers, each one using the heat generated by the previous layer for computational purposes, whereas the innermost layer is the one absorbing both heat and light directly. And as it slowly radiated outwards, this massive computer, which in the swarm concept would be made up of massive clouds of computronium. So basically, computers at the cellular or atomic level. Tiny but powerful, given that they're the result of such advanced nanotechnology or even smaller, pico or femto technology. Each one would have, theoretically, the computing power to contain an entire person's consciousness. And Bradbury was quite revolutionary in suggesting this concept. Like many others that he made over his lifetime, he was instrumental to future studies and the search for extraterrestrial intelligence. And this idea has also been explored in fiction, not the least of which was by Charles Stross in his book Accelerando. Because basically this concept envisions how a species may eventually need to rely on computational resources that are so massive they reach a stellar scale, or that they have chosen to shed their physical bodies and live on indefinitely as part of a massive virtual existence. And in Strauss's book, in fact, it contained mentions of how countless people had quantum vectors of themselves. So basically, it's like every decision you've ever made in your life, it produces another outcome. And all the different outcomes that come from that are all essentially quantum vectors related to quantum physics, right? Referring to different possible outcomes in the behavior of subatomic particles. So in fact, if this Matryoshka brain is essentially one massive quantum computer, it would be able to simulate innumerable possible lives and versions of different people. So not only could it house trillions of people, but also unfathomable numbers or versions of them. And the reason why this is considered a possible resolution to the Fermi paradox, which we talked about in a previous episode, called the transcension hypothesis, is because if a species did choose to forego their physical existence in their physical bodies and essentially turn their solar system into a massive computing structure, it would be very hard to discern their presence. We would basically be looking around for stars in what would appear as dim stars, and large infrared signatures would in fact be similar to a Dyson sphere, a massive computer in which all the intelligent life is contained in there, which may or may not be producing any discernible signatures and would likely be indistinguishable from cooler dwarf stars. Now, these are all examples of megastructures belonging to a Type 2 civilization, clearly. If we go up the scale, we find that these concepts, several have been proposed, and they become even wilder. However, there are still many Type 2 civilization megastructures that I still need to touch on. And I'm going to need to save that for our next episode because the list is long and I do love to get into detail. There are several personal favorites of mine. The Matryoshka brain is certainly one of them. Dyson structures in general are interesting, but I do tend to gravitate towards the most exotic and, in my opinion, fascinating ones. And of course, those which offer what would seem to me to be a coherent explanation for the Fermi paradox, i.e., why haven't we heard from advanced intelligence? Why haven't we seen evidence of it? Megastructures are not only a possible suggestion for what SETI researchers should be on the lookout for, they're also often used as a means of explaining how an advanced civilization could go unnoticed. And they offer a preview of what humanity's future could look like. I say could because the whole notion of exponential growth, that is one model, whereas there are others. The idea of sustainability, using the resources we have, creating a circular economy, etc., kind of things we talked about with Marie Bajah in the previous episode. That too could be what lies in our future, partly out of necessity, grim necessity, but also just because it's better than constantly looking for the next thing to pave over to make way for additional people. So, in our next episode, we'll be talking more on Type 1 level megastructures, which include other personal favorites of mine, like the Shkadov thruster, a very interesting take on the stellar engine concept, in which a star and a megastructure are paired so that a species can transport its entire solar system throughout the galaxy, as well as Alderson disks and more. We'll also look at what a Type 3 civilization would be capable of based on various theoretical scientific proposals. And then, hopefully, we will take a look at, in a third segment, smaller megastructures, examples of what a Type 1 plus civilization would be capable of. So, stay tuned for that and other new exciting episodes in which we will also look, as promised, the web naming controversy and some more exciting interviews with some talented professionals in the space industry and science communicators who are conducting vital education and outreach with the world. In the meantime, thank you for listening. I'm Matt Williams, and this has been Stories from Space.
We hope you enjoyed this episode of Stories from Space podcast with Matthew Williams. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. you can always find us at the intersection of technology, cybersecurity, and society.